just met you, and it's crazy, but here's my number, so call me maybe. It's hard to look right at your baby, but here's my number, so call me maybe. Hey, I just met you, and this is crazy.
Good morning, class. Today we're going to learn about spectroscopy and blah, 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 and you see blah, blah. Excuse me, students, I need to step out for a moment. I'll be right back. Hello?
Hello, and good morning. This is the President of the United States of America. Is the professor there? I have an urgent task that must be completed with great haste.
No, I don't know where she is, but I can take a message?
No, this must be completed as soon as possible. Are you a student in Chemistry 130?
Yes, but I don't know anything about chemistry.
Nonsense! This is what's going down now. There's a gas leak at Dow Chemical. We are not sure what it is or what it does. Could be a very harmful chemical. We desperately need the expertise of introductory chemistry students to save the city, no the state, no the country, no the world, no mankind!
Okay.
Great. This is all you need to know. We're sending you a 10 milliliter sample of the gas right away. Good day and good luck.
Wait, what's going on? I think we need to save the world. Wait, what?
So, what exactly do we have to do?
Well, we're being sent this container of mysterious gas that Dow Chemical and the president wants us to analyze. And, I mean, it might be harmful or something, and I think they wanted our teacher to do it, but I don't know where she is, so now it's up to us to save the world.
Alright, well I know you need to use a spectrophotometer to analyze the gas, because every gas has its own, like, fingerprint thing, but I slept through all the lectures, so I have no idea. Anybody else got any clue?
Okay, so we know that each gas has its own fingerprint, but why is this? To begin, it starts with the idea that an electron can only have one specific energy values in an atom. These values are simple integer numbers that are called the principal quantum numbers. To simplify this concept, we can compare the idea of quantized energy to a modified game of hopscotch. Imagine that you are playing a game of hopscotch. First, we need to lay down some game rules for the game. The rules are that each person can only have their body in one box at a time, meaning that nobody can be in between the boxes or be in more than one box at a specific time. To make the game a little more difficult, we spread out the boxes far from each other, with each box getting a little closer to the next one as we get farther through the game. The game might look like this. Now imagine that you're playing the game. You start in square one and you want to get to square two. You can't be in between the boxes because then you could lose the game. So you have to take a big jump from box 1 to 2. The next jump is from box 2 to 3, which is a much easier jump. A spectrophotometer is used to measure the transmission or absorption of solutions, solids, that are transparent or opaque, or gases. There are two common types, a double beam spectrophotometer, which compares the intensity between two different light paths, one with a reference sample and one with a test sample. There is also a single beam spectrophotometer that measures the relative light and intensity of the beam before and after the test sample is inserted. The spectrophotometer quantitatively compares the fraction of light that passes through the two solutions. So what happens is the light source is put on the sample, and then a fraction of the light is either transmitted or absorbed from the sample. This light is then imaged onto the entrance slit of the monochromator, and the monochromator separates the wavelengths of light and focuses each of them onto the photodetector, which measures the intensity. The first thing that we need to do before taking the reading on the spectrophotometer is to place our mystery gas in front of a white light. When the spectrophotometer is placed in front of the white light, it shows a complete spectrum. The spectrophotometer works by filtering the incoming light into a small, thin sliver. This sliver of light then hits a prism. The prism works because of the difference in the refractive index between glass and air. When the light hits the prism, this difference causes the light to bend. The angle at which the light bends is different for each wavelength of light. The result is that the white light creates a rainbow. This spectrum is different for every element. When a gas is placed in front of a white light, the gas absorbs some of the colors. This means that when the light is refracted through the prism, there will be gaps in the spectrum. This is called an absorption spectrum. We can identify what the gas is by figuring out which element spectrum corresponds to the missing wavelengths.
To the spectrophotometer!
Yay!
We found it!
Okay, now that we know how to work the spectrophotometer, we can insert the unknown gas and find out what it is.
Okay.
Okay.
Turn it on.
On.
Oh,
All right, there you go.
We know what it is!
All right. Hello, is this the President of the United States? Yeah, great. Okay, so these are the chem students that you asked, like save the world for you and stuff. So we've got your results here. So it looks like the unknown gas is neon. Properties are orange in color and it's non-toxic, so nothing to worry about there. It's rare gas found in the atmosphere and it's not harmful to humans unless it's ingested in large amounts. So, it's really not bad. It's used in advertising signs, so maybe those guys should be careful. But other than that, I think we're good. It's really harmless gas, so next time just be more careful, dude. Cool. All right, peace.
Yeah!
So like I was saying about Lewis dot structures, first the two electrons, their orbitals overlap to make a sigma bond, and then a second pair of electrons overlaps to become a pi bond. And that is how you get the double bond between carbon and oxygen. That's all for today, class. I'll see you tomorrow.
I get it!
Get what?
Spectroscopy. Weren't we just talking about spectroscopy?
We've been
I
talking about
think
Lewis dot
you're
structures. It's on the
confused.
board. I don't know what's going on.
So it was all a dream?